Okay, guys, this video lesson, we're going to start off Unit 1. So our first unit is all about one-dimensional motion, or sometimes we just say 1D motion, okay? So basically what we're going to be studying is movement that is all linear, okay? So it's either up or down, left or right, east or west, north or south. But we're not going to curve anything, we're not going to launch anything and have it fly through the air where gravity affects it. Basically just the most basic type of motion is moving in straight pathways, okay? For us to do that, we need to first of all identify a really big chunk of terminology, okay? So one thing about the world of physics is it is sometimes, and even the world of science really, is sometimes seen as its own language, okay? Now we all are speaking English here, and you can study physics in any type of language, you know, French, German, Mandarin, whatever it is. But at the end of the day, we need to be able to actually be able to talk physics, okay? It's kind of like being a musician where you need to be able to talk the music terminology, okay? So here's some terms that we have to be conscious of and be able to work with. So first of all is our descriptors, okay? Now, descriptors mean these are things that we can use through the whole year, okay? They're not basic on motion. Don't do it necessarily with physics. They're just things that we use to talk about. First of all is change. So a lot of times in physics we talk about the change in things. Change in time, change in velocity, change in acceleration, change in displacement, lots of change. So anytime we talk about change, we're going to use that Greek letter delta to help symbolize that. Okay, so that's a term that shouldn't be new to you, but want to make sure we're talking about. Okay, speeding up and slowing down. Again, simple terms, but when we talk about speeding up, that means our velocity or our speed is increasing. Okay. Or getting further away from the 0 point. Now, slowing down means you're getting closer to the 0 point. Notice I don't say getting bigger or smaller. I talk about going away from 0, okay? Because 0 speed or 0 velocity is the smallest we can have. We can have negative speeds and negative velocities, okay? Constant. And that's just what it is. If something is constant, it's not changing. Now, constant could be moving, or it could be sitting still. So don't think of constant as being just sitting still. Okay, if you have a constant velocity, you're still moving, but your speed or velocity is the same. Increasing and decreasing are similar to speeding up and slowing down, but again, we're not referencing a velocity here. So if you are increasing in something, the number is getting bigger or away from 0. If you are decreasing, that number is getting closer to 0. Okay, we want to be really careful about that. Again, we're going to find out real fast in physics that negative doesn't necessarily mean smaller for us. It just means further away from 0. And 0 is always our smallest value possible. Okay, which brings up 0. Okay, 0 is a point that's really special to us. Okay, we really like 0. 0 makes our math easier, and 0 is always the minimum of everything that we can do. So we have what's the slowest you can go? 0. Okay. What if you have no acceleration? It's 0. Okay. What if you can't fall any farther? It's 0. So zeros are good for us. It's our minimum. We'll be using x and y coordinates a lot in here. And anytime we talk about the x coordinate, we're talking about horizontals. Anytime we're talking about the y coordinate, we're talking about verticals. Okay. So throughout the whole year, we'll talk about what if something is moving both horizontally in the x direction and vertically in the y direction. Now, for this unit, one-dimensional motion, we'll be working with either just horizontal x or just vertical y. Okay, that brings up some other descriptors for us: up, down, left, right, north, south, east, west, plus, minus. All of these things are going to become important because as you describe motion, to say something is moving just 20 miles an hour tells half the story. The other half the story is which way is it going. Okay, so the world of physics, we often have to track both the magnitude, a numerical value, like 20 miles an hour, and direction, east, west, north, south, that kind of stuff. And that's plus and minus. Plus and minus can also be used to denote direction, okay? And it's necessary for us, actually, when we do physics problems or mathematical problems in physics, because if something is moving north and something else is moving south, they can't have the same sign. Okay, so we use the plus and minus to indicate opposite movement or opposite direction, and we'll do that in our math a lot this year. Okay, so these are descriptors we're going to use a lot. Now, basic motion terms. All right, so these are terms that we're going to be using from starting off the very beginning of the year to the very end of the year. We'll still be talking about these basic terms starting in motion, but anytime something moves. So position, okay, your position is whatever point you are at on an XYZ coordinate plane. Okay, so when we talk about position, you could be 5 steps from the origin, you could be 22 meters away, you could be 15 kilometers high. It's that one spot, it's that X, it's the Y, or it's the X, Y, and Z all put together. Okay. Anytime we have motion, that means there's movement. Okay. The absence of motion would be no movement. So anytime we something is in motion, it's just moving. That's all it is. Time is big for us in the world of physics because our lives move through time. And anytime that we have motion or movement, we end up having to track it through time. So this is kind of one of our big ones. I would star this one for sure because the concept of tracking time is really a key part of most of the stuff we do in physics. Now, if you have a certain position and you have motion through time, you're going to travel a distance. Okay, so distance is basically how far you travel. Now, you may think that distance and displacement are the same thing. Okay, and they really aren't. When we start talking about distance and displacement, the distinction is distance is just how far you go. Okay, where displacement is a measure of where did you start comparative to where did you end. Okay, so an example of this I always do is a track. So if you're a runner on a track, and here's our track, and you're right here getting ready to run, and the gun goes off and you run to here, okay, you would measure everything around the curve to be your distance. Okay, so you ran about a 200 meter, let's say that's a track. I know it's not where you really line it up. Okay, however, your displacement in the world of physics would be from here until here. Okay, so that's the difference. Because a lot of times in the world of physics, we really don't care about the path. We care about where'd you start and where'd you end. Okay. Now the crazy thing is, if you do a 400 and you start here and you run all the way around the track and get back to here. If you go around the track, that's 400 meters. However, that's your distance. If I ask you what the displacement is, that would be 0. Okay. Now that seems really weird, but it's useful for us because at the end of the day, if we want to track how far we have versus time, we need to do displacement. Okay. It actually makes our lives easier mathematically later on. Right. Speed. Again, we'll talk about speed versus velocity. Speed. Sometimes people think that speed and velocity mean the same thing. Okay. Speed is basically how fast you're going. Okay, so you're going 20 miles an hour, 30 miles an hour, 5 miles an hour, whatever it happens to be, 10 meters per second in a SI system. Velocity includes direction. Okay, so it is speed, but which way? Okay, so you're moving 22 meters per second east. You're moving 19 kilometers per hour north. You are moving 30 centimeters per second to the left. Okay, up, down, plus, minus. So velocities always include some sort of direction with it. Okay, so and there are times that we only care about the speed of something, the magnitude, but a lot of times we care about both the magnitude and the direction in physics. Within velocity, there are 2 different types of velocities we'll talk about. We have an average velocity. Okay, so average velocity basically is taking something that is changing velocity over time and finding that average of that. And we'll actually show you how to solve for that in our sense of problem solving here. This becomes helpful for us because if we have accelerations or changes in velocity, sometimes we can just use the average to do our math. And then we always have our instantaneous velocity. So this is just a velocity at any given one point in time. Okay, so if we're tracking the movement of a car and it goes through traffic and it's starting and stopping and accelerating and it is curving, if we only care about the velocity at one point in time, that's our instantaneous velocity. Okay? I often talk about this is what the cop gets you on the radar gun. This is your instantaneous velocity. He doesn't know how fast you went the whole time you were driving. He doesn't know that 5 miles before you were going 80 miles an hour and now you're only going 72. But he captures your instantaneous velocity, even though your average might be different. All right, last one we have on our list here is acceleration. Okay, so accelerations are anytime we change velocity. All right, so it is basically just that. There's not much more to say about it. If we change a velocity, we're accelerating. Okay, you may be looking for another term of deceleration, and we're going to find out as we go through this unit that the term deceleration is not one that we actually use, because an acceleration is any change in velocity. So an acceleration in the world of physics can actually slow something down too, which will be fun for us. Okay, all right. We got stars on these three: displacement, velocity, and acceleration, because those are considered vector terminology for us. And what vector terminology is, these are things that include direction. Okay, so anytime that we talk about something being displaced, or something having a velocity, or something having acceleration, we also have to include the direction for these substances. Without the direction, we can't solve for the mathematical problems we're going to get into, and we can't complete the picture of what's actually happening with the motion. Okay. Now, in class, we're going to do a little volunteer activity, and I'm going to ask students to do these three things: move an object 30 centimeters. Now, if we have an object, say right here, and I say move it 30 centimeters, okay, 30 centimeters could be, if that's 30 right here, to this position. It could be to this position. It could be over here. Okay? It could actually come out of the screen and float above the screen, or go into the screen. Okay? So in the terms of displacement, we need a direction with this also. Okay? So here, moving an object 30 centimeters, that's really only saying a distance. Okay? To really tell the story, to get people to do the same thing, you say move the object 30 centimeters to the left, or 30 centimeters north, or 30 centimeters above the tabletop. So you'd have to give a direction to it. Same here for velocity. Okay, walk 2 miles per hour. Okay, walking 2 miles per hour is about what you do down the hallway. It's not very fast. It's just a nice little walk. But if I say walk 2 miles per hour, and I wanted every person in the room to head the same direction and end at the same place, or move in unison, that wouldn't happen. Okay, because I don't give a direction to it. So the idea of being a vector, okay, vectors a lot of times are represented by arrows. You may have seen that in your math classes, is that you're looking at a direction. So walk 2 miles per hour east, walk 2 miles per hour towards the door, walk 2 miles per hour back to the lab. Okay, so giving a direction is what we need for those idea of vector terminology. Okay, and that's what gives it the difference. So the direction piece is a new part relating back to the idea of being a vector. Last one, start at a speed of 2 miles per hour and accelerate. Okay, so if you're at 2 miles per hour, if you accelerate, you either have to speed up or slow down, right? You can go to 3 miles per hour, 4 miles per hour, whatever you want to do. You could break into a jog or a yog. It could be a long J, or you could slow down and stop. Okay, in either case, you're changing the acceleration. So here, if we accelerate, we could talk about start at a speed of 2 miles per hour and accelerate to the left. Okay, if you're walking to the right, you'll slow down. Or you could say accelerate to a stop, which sounds really weird for us, but to accelerate to a stop means you're slowing yourself down to a stop. Okay, think of like brakes. Brakes accelerate us to stops. Okay, so having direction is really another key piece of the world of physics. It's not only numbers, it's also direction, or where it's going. All right. Okay, that is the slides on terminology. That's our introduction to physics. We will start with how we do this graphically next. Thank you.